Before we leave 11.1 behind, I want to show you a left and a right-tailed test respectively, because they both could show up, and they're a little bit trickier than the two-tailed test. But before I even do that, I wanted to show you some handy feature of StatCrunch. So 11.1, number 11, is a left-tailed test. And if you click on it in StatCrunch, right over here, you click on that, you can see the cells with all that. Then I can copy and paste without having to go to my Excel files. Isn't that great? I was excited. Maybe you're not as excited. All right, so I'm gonna first of all find the difference. So di is equal to xi minus yi. Oh my gosh, I can't spell. Okay, so that's gonna be equal to x minus y, like that. I'm gonna find it for each one of them. There we go. Okay, so now that we've got that was part A, actually, was they wanted us to find that. Then they want us to compute d bar. And you would have to do this anyway, even if they didn't tell you to, you're going to have to do it. SD, and you're going to need, that's standard deviation, sub d, and you're going to need n, which is the count. So d bar would be equal to average, it's the mean of these differences. SD is equal to ST DEV. Okay, if it's old school Excel, you can just do that, but I'm going to do .s because I've got the newest Excel. There we go. And n would be the count. And I know we can find it rather simply, but if you have a larger data set, it helps to know how to do the count thing. Okay, that's part B right there for this particular problem. All right, then part C, they want us to test whether mu d is less than 0. And so this is going to be a hypothesis test. Step 1, they want us to write down our hypotheses. Let me go grab those out of Excel. Wait, hold on one sec. There we go. They explicitly said they wanted a left-tailed test in the instructions, so that's fine. All right, alpha. Alpha is equal to 0.05. Again, that's given to us in the instructions. Step 3, we need our test statistic, which is T0, which we've learned before is d bar divided by parentheses SD divided by the square root of n. Close parentheses, close parentheses. There we go. Awesome. Step 4. All right, now again, we have a couple options to us, and I'm going to try to show you both. Classical, you're going to need a critical value. Okay, now how do you do it? Well, this is going to be a little tricky. You need a left-tailed one, so it's going to be equal to T dot INV, right? And this is all alpha, so take 0.05, and degrees of freedom is 7, take away 1. Cool. So it's negative 1.9. All right, now how do you do it with older versions of Excel? This is where it gets a little dicey. So if you want T inverse, okay, and then you say, okay, it's 0.05. The problem with that is that it's automatically two-tailed, the way T inverse works. So it wants this to be two-tailed. So if you say 0.05, it thinks it wants 0.025. So you actually have to times it by 2, and then tell it degrees of freedom, which is 7, take away 1. There we go. The T inverse function works great for two-tailed tests, and it stinks for one-tailed tests. So you're going to have to multiply alpha by 2 in order just to get the area you wanted, right? Because otherwise it was going to cut it in half, and you don't want that at all. And while you're on the subject, you actually want the negative one of that, right? Because it's giving you the right-tailed thing. You want the negative. You want negative T inverse. A giant pain. New Excel is much nicer. T dot inverse, then you just tell it alpha, and you tell it your degrees of freedom, and you're done. All right, that's your classical method and way. If you do a p-value, it's equal to T dot dist. Okay, then your x is negative 2.23. Degrees of freedom is 7, take away 1. True. There you go. All right, now what about new or old Excel? Well, we'll have to see that in the next one because it's complicated. See you then.